Okay, so I have filed this blueprint to discuss a bit what's taking the biggest time. So we all know that the updates and upgrades, whether it's only update or disk upgrade or anything like that, take a bit long. And if someone clicks that button, show me the details, or that expander, anyone can see that some actions are repeated. It's too serialized. So we have, it seems for me, too serialized. So we have download, prepare, unpack, update, anything like initramfs and ManDB and things like those after every package which seems to affect these indexes or whatever they are. So I'd like to discuss a bit about what's your idea, why are these taking so long? Why do these have to be repeated? Do these have to be repeated? And how can we improve this or make a bit faster?
Well, I think on the repeated subject, I think this is pretty much a solved problem with the triggers. So we don't actually call ldconfig or update docs, etc. repeatedly anymore. So I think from my perspective, the main problem here is the serialization. So like we update everything, like we update the lists, and then we we download the lists, and then we download the packages, and then we start unpacking, etc. So, do you agree?
Yeah. Well, so the triggers are in so far a problem as apt will order the install in discrete unpack configure runs, and the triggers are run in between. So it's not like the LD config is triggered right after everything else is finished, but it will run in between these stages.
Yeah. Does it have to?
Yes, it has to.
It would be nice if we have triggers to just do it right at the end. ManDB just updates man pages. You don't need it while upgrading, but
But anyway, this is probably accounts like for like 1% of the upgrade time.
ManDB is actually, so we have some statistics. I mean, the first problem we have is we don't have any good data currently. We know it takes long, but we don't know exactly why and where. Except for the obvious one that downloading and installing is not happening parallel. But like what actually takes all this time when we install it? We don't have good data on it. So like my proposal would be that someone would actually go out and collect good data. We have a lot of infrastructure for doing this. The automatic upgrade tester has a mode where it can collect, like where it basically takes all the output from the depackaged status pipe and adds timestamps to it. So we can use this to figure out, ManDB, like we also get trigger information, so we know ManDB, for example, contributes, like, I don't know, 1 minute to the 40 minutes the entire thing takes. The current, contributes like 5 minutes, whatever. So this is the first step, in my opinion, gathering data. The next one interesting thing you raised, David, is some triggers are required, like ldconfig. Some are more optional, like ManDB. We could, if man pages are not available during, the new one's not available during install, and that's not a big deal. So having a notion of, required triggers and kind of delayed triggers, maybe.
I mean, ldconfig isn't necessary during the upgrade.
There are a couple of special cases where it is. I think they're not in general, but in the case of things playing about LD also
right. In that situation, though, you mustn't use triggers anyway.
True. Yes. And indeed, we have to.
Right. So it would be possible to run apt with have apt run deeply with the no triggers flag.
Okay.
I tried that. And we have problems with pre-dependencies because I will fail, depackage has a bug report for it, and that's a single comment. And I don't know which triggers I have to run to satisfy the pre-dependencies.
Are triggers really, so they take time and people notice them because they show up, but do they really come even close to dominating runtime of an upgrade?
My gut feeling is that it's less than 1% or so.
I thought they were...
I mean, the thing like half of the time for me is downloading, the other half is unpacking, like the huge I/O block that it takes to unpack all the files.
But right, I mean, you kind of notice them because they're at the end, so after
Right.
you got to the point where you thought you were kind of done, then you got the triggers, so I think sort of psychologically they're noticed, but
Yeah.
they... I didn't think that they actually dominated runtime in a reasonable way.
So my gut feeling is certainly that we could just about half the time by just parallelizing, downloading, and installing.
Yeah, I mean,
This is like the big obvious thing to do first, which would give us most benefit.
Would there be any value in parallelizing triggers? I get the feeling that there doesn't seem to be any kind of dependency relationship between them anyway. And I get
Yeah,
the feeling
because they
that
already do this at some point, right?
right, and I get the feeling that you often have, one of them is CPU bound, one of them is disk bound. It seems like the sort of thing that
You've probably got multiple cores now anyway.
So you've probably got... Oh yeah, multiple cores indeed.
So, yes, I think if the maintainer scripts are not making the assumption that everything is single-threaded, that's possible in principle, although implementing it might be exciting.
Yeah. Remind me, I didn't think that ManDB was quite that slow. I'm entirely happy to take an action to optimize ManDB further.
So this is very preliminary data. So
Yes.
it's,
Right, but that's a clear dominance. So,
Yeah.
I had thought that I'd got ManDB to the point where it wasn't a significant problem to run it on upgrade,
This
but
is
that
not-
shows that I'm wrong.
This is Maverick Tonelli.
Right.
And this is data I collected like last night, so it may be buggy, but
Sure.
this is what I would like to see, like having proper data sorted by runtime, what is actually contributing to.
What is
So what is-
exec?
What does that mean?
Just calling dpackage before it reports anything to the status type. So from exec dpackage to dpackage actually reports anything.
Right, so that's
Yeah.
parsing the status.
Parsing the status file and all this stuff.
So what does that mean? Like 22 seconds, I assume, software center. Is it the time to install that package, or is it the time that the process called software center runs? Or?
This is an upgrade from Maverick to Nelly, and it's the time it takes for this specific package until it's fully installed, I believe.
This is like the sum of all of the
So
time
this is-
spent processing that package.
Okay, so this is like download, unpack, and configure.
Not download,
not download.
just the depackage times. And
Okay.
ManDB, of course, contributes because of the triggering stuff.
Right, so you'll be seeing it in several different unpack sequences. But,
So that means, sorry. So it means 45 minutes is just unpacking and installing, it's not downloading. Yeah.
Do you know how many times, for example, the ManDB trigger is
We have the data,
I
but
would be astonished if it were not once per unpack run, essentially, because anything that installs in that page will...
right? And how many unpack runs do we have in a particular upgrade? Do we have any idea?
we have like the data residue.
So those actual packages, a single
20
unpack. So
maybe?
20.
20? Like a rough number. 20? 30?
So if we could fix the pre-depend,
Nice.
ManDB will be a lot more efficient if it is run fewer times, because it is having to at least get them to
right,
run.
if we could fix this pre-depend problem, we can turn that 87 into 4. Right? If 20, I'm taking your guess of 20. Right?
Right, because it only needs to be run, well, it
Approximately.
doesn't scale linearly, but 10, say.
Yeah.
I guess.
And likewise, we're probably building the init RAMFS rebuilding the init RAMFS a number of times, and that's going to be very expensive.
And that's showing up on Linux image.
Yeah.
But actually, that's showing up in RAMFS tools. That's quicker than I would have expected.
Weird, because this seems like the single big thing which
So
takes
what's
more.
Linux image 2638 blah?
Right, that is building it itself as well, although those numbers are, I want to see the actual.
Yeah, it's like I said, like this may be buggy. It's just, this is the kind of data I think we need.
Right.
Okay.
Like I haven't done any verification on these
Another-
numbers if they actually add up or anything like this.
Another suggestion, right, so the second item on that list is duplicate exec, and a large proportion of that will be passing the status file. And I did an experiment a number of years ago where I replaced the ad hoc character by character status file parser with a flex grammar.
Right.
And that produced like a 30-ish% performance improvement. But at the time, there was like this whole like row with Guido over the GUI rather about the triggers thing, and
Right.
so yeah. But you know, I've still got that branch, and you can probably.
Another interesting thing to measure would be to do an upgrade with Eat My Data to see how much the IO weight actually contributes to this, because what's left is actually the bits which we can optimize, I think.
Right.
So I don't think we can do a lot about the IO part of it, because it's just there.
Right.
But it would tell you more closely the parts which are CPU intensive, etc.
Yeah, that's a very good point.
So I know that there was some work done on.
Eat My Data.
It
essentially takes F-sync away.
Right.
Oh, okay.
I know that Guillaume did some work in Deepage to order, what was it? It was ordering files and reads by FIE map order. So you get the extent map of the disk and figure out the optimal read ordering for everything. And apparently that was a fairly significant improvement. Is there anywhere else we should be doing that?
Oh, this is rotary disk? Or?
Yes.
Right.
This
Okay,
is,
so it would actually matter.
This is a KVM instance on a rotating disk. That's
Okay.
not very slow, not very fast, but also
Like
not
on the
very slow.
rotating
It's a
virtual disk.
average
Right.
kind of disk. I mean, it's not, like I said, it's not a 10K disk, but
Okay.
I think it's a 72K disk. Just
Mm.
you know.
So yeah, so I guess what Colin said, like the reordering seems to be one way to actually improve the I/O part of it, but just for the measuring was that the without F-sync thing was just
Yeah,
interesting.
definitely.
And then of course, like how much time does it actually take it to download all of this?
Yeah.
Like on like my DSL 6 megabit, it only took like 30-40 minutes to download everything.
Right. Well,
which
we
is
discussed step delta
half of the
separately,
time.
which will, if we do that, that makes a giant difference.
And also-
I expect because it's essentially half of the time.
Yeah, or even less than 25% of the original size is kind of what we may get if we are lucky.
For that.
But yeah, and doing install and download in parallel is currently, like with the current code we have in app, difficult.
Because
It will get useless if you add step delta, because that has a huge impact on the CPU usage. So the package runs will be slow. So you are basically, you can't parallelize it again. So either or add.
well, download doesn't really take lots of CPU.
It does if you're trying to apply dev deltas.
Right, I mean the actual downloading is just waiting basically.
Yeah.
If you are using dev deltas, then the dev delta guy has done a crazy
Right.
parallelized thing, so to optimize this already, and
Yeah.
it's already using, a fair amount of your computational resources as well as the network. So at the very least, you should do first one thing and then reconsider.
Right, okay.
You have a summer. What's the summer of code project you have in apt at the moment?
This is about ordering, so the app ordering, so that we can produce an ordering that is currently, like, we get one ordering that we can't optimize for anything. And I would like to see an ordering where we can optimize for the least invocations of the package or the least broken packages at any point in time. So I would like to have like a ordering for safety, so that So that you actually
equivalent
can
to minimal chunks.
minimal chunks, exactly. Minimal chunks, which is currently implemented outside of the app, inside the app, basically, so that you can stop and upgrade it, you know, convenient time without waiting for like hundreds of packages to get configured. Obviously, this would be
very
slower.
slow generally.
Right. This is why, yeah, like I said, like we want to have optimizations for different use cases.
So that would also help for doing upgrades with low disk space available, or like
Yeah.
on small hard disks.
Exactly.
So
If you
download
have-
the chunk and then install it. And
Then
If you
download the next
do
one.
maximal chunks, then you will essentially, the constraint will be predepends,
Yeah.
and that will almost, you know, if you think about a naive answer to the predepends problem, which is, well, we'll just do the triggers every time we come across a predepends,
Yeah.
that's exactly what that would be. And it would probably reduce the whole thing to like 3 from 20.
Right. So
Because you could, you know, you only need as many things as you have depth
Right.
of predependent
Right.
chain, and if you have several separate predependents, you can probably do them together.
Right, and it's not inconceivable, given how many people I still see applying predepends incorrectly. So I have an argument about once every 3 or 4 weeks in IRC, which results essentially in me explaining what predepends are for. And I expect that not all the people who are applying predepends ask about it on well. So I would be astonished if there were not some places where we could get rid of predepends and reduce the depth.
But yeah, but if we change app so that it runs with no triggers and only and trigger minus pending every time it encounters a predepends, then there's more of an incentive for people to fix these problems.
Particularly if we could get
Just for the record, it's already implemented, and I run it for a year or so. It works, but yeah, it doesn't have a lot of benefit as long as you are running the package configure only triggers or however it's called. Really, so
You currently run it on every
on my system,
I
yeah.
mean on every predepends only or after every unpaid run?
Yeah, let's check the man page.
I mean, we can, like this is like we can test these options in the automatic upgrade tester, giving using different settings and figuring out how much benefit we actually get. So I put this down as an action item.
So there's no ability at the moment in debugger to calculate what triggers you would need to run to satisfy some predepends and do only that. And also debugger has a bit of a problem at the moment still doing both configures and doing first configures, which are essentially like trigger processing, and then unpacks. So that might be most easily implemented in our app. I don't think it's easy to, does apt know at the right part of the code whether it's broken the chunk up for a predependence?
I believe it does.
What does it?
Does it know it, like why it broke up? If it was because of a predepends or not? I believe it does, right?
Yeah, I think. Yeah. Sure.
Another thing to do would be to defer unnecessary configures in apt. Right, if you're trying to do maximal performance, minimal safety, you would want to configure only the things that you need for the predepends and do all the other configures right at the end.
And that's exactly what I try to do. I'm giving all configures which are not really needed, which means I only configure on pre-dependencies, and I have to run, trigger pending after these configurations. As I need to run all triggers, or otherwise the pre-dependencies are not satisfied.
What sort of increased bug rate from packages do you see out of that? Generally the greater the interval between unpack and configure, the more that broken packages have some kind of problem. I don't think that's an argument against doing it, but it's an argument for making such a change early.
Yeah, and yeah, in theory it doesn't change anything in app,
Right.
as it already does, yeah, a lot of unpack and RAM, a lot of configure.
Right.
So, and I'm just leaving out the configure explicitly, and yeah, so it doesn't change anything in theory. And it works for me, so but yeah, but I'm a crazy people.
We can test it in the automatic upgrade tester. I mean, we can run various scenarios and see if it breaks or not.
Do we have a possibility now to also run this against a large chunk of universe, which doesn't conflict to each other?
Yes.
Because it traditionally seems to be the point where more problems come in because we test it a lot less often. And
Right.
like in most cases which I've seen where people shouted at me saying upgrade broke, it was because of some forgotten universe.
Yeah. Yeah, we do have more disk space now, so we could. It turns out that D package becomes pretty slow when it has too many packages. Like I was testing, it was like 50,000 packages installed, and like the real memory requirement it had were like 500 megs, the package process. So that became a bit of an issue, and it was also very, very slow reading the packages, like just the list files basically in valid D package. But I guess there's very little we can do about this. Okay.
There used to be code to use a different data structure for the in-memory version of the list files, which had a much smaller working set. It used more memory, but more virtual memory.
Right.
But it had much more locality of reference, so it was good for small machines. But somebody noticed that it used more RAM, but the low memory option used more virtual memory, and then they deleted it. That wouldn't help with parsing the status file, which would take a lot as well.
And yeah, but like I only looked briefly at it, but like my impression was that the problem is actually reading all these list files, that it's not so much the status file, which was big, but not terribly big. It was really an insane amount of data it had to read from the list files, and it's a pathological case. I mean, like 15,000 packages is quite a bit of.
But did you actually have the impression that this
the
scales?
startup would be very slow, but also you would find that
Generally unpacking.
everything will be slow because it's updating this thing in core.
Yeah.
It's possible that the low memory data structure, which you can probably still find in some old version and try, has a better cache performance.
So did you have the impression that this is like increased more linearly? Because if you run it in 20 chunks and you add the time together and it's still about the same time, then it just might feel slower, but not actually be slower.
How do you mean?
Well, like if you just do all the unpacking configure in one run and it feels slow because, as you said, it takes a long time to read the status files. If suddenly it would be faster if you run it in 20 steps, but then you have 20 times the amount of that faster time, which might not necessarily be faster.
Right. And also the drop, running it 20 times makes sense, but we don't get the benefit of checking for conflicting files anymore. But yeah, just we still catch all the post-ins problems, so it's probably still worse.
No, I mean for runtime. Like at some point you need all of the list files anyway and build them into the packages brain.
Right.
So I was just wondering whether this scales more than linearly, so you think it's a quadratic.
I don't know.
No, okay.
It's the data structure is hash
Okay.
so it's like roughly login access.
So that means it only gets like more than linearly worse once you start hitting this wall.
Well, because you're also going to have a cache problem,
Right.
right? And on a small system, much of that stuff may fit in cache, or at least parts of it that you're using. Whereas on the bigger you get, you may blow the cache and then suddenly it will perform a lot worse. I don't even use that. Measurements of that. But it's quite, that part of Deep which is quite self-contained, you would probably dig out the old data structure file and just chuck it in. It's just the path name to, there's a lookup from path name to little struct, and that's all you need.
Any more ideas or suggestions on this problem?
We need to do something about the init-RD generation, right? We need to make sure that only happens once, because if you add them up, there's 40 seconds there from init ramfs tools and Linux headers. Assume that's generating the init ramfs, and then there's another 52 seconds right at the bottom.
Yeah.
So that, when you add it all up, that's the top of the list.
It certainly seems to be the one trigger kind of thing which takes by far the most time. I've seen it run like 5 times, even on an intra-development upgrade.
Yeah.
Right, and it's almost particularly for people upgrading through development, this happens quite a lot, because anytime we upgrade the kernel or anything, vaguely plumbing-ish or practically anything, the inner ramp.
Yeah, I think also things like UDEV do it, and like pretty much everything is just inside, and now upstart.
I think a lot of the time is spent compressing the image. Can I make a radical suggestion? How about we compress it with -1, and then at boot time we schedule a thing that says, well, maybe we want to recompress. We've actually booted this, so maybe we want to recompress it.
We actually looked into that a while back. We initially were compressing with -9, and we switched to just default, and that seemed to be a pretty accurate increase in performance of that, or at least that at the time. Sure, I mean, it may be worth looking at it again.
There is, of course, a risk that we produce one, if we don't compress it, that's so large that it can't be booted somehow.
Right. I'm just looking up it. I think we left in the changelog a note about how much it helped. I think dropping -9 and switching to just default, which is I believe -6, was a size penalty of 1%. And it was, oh, there we go. The time, right? So here's the bug. I think it is from Tolef. I think the default GZ compression level should be changed to -6. In my measurements on the Ubuntu system, the size difference between -6 and -9 is about 1%. While the time needed to compress the init ramfs goes from around 15.5 seconds to around 2.5 seconds.
Oh, really?
So that was the state when Tolef did that. I haven't rechecked that recently, but 2.5 seconds, if that's still true, I don't think it would be a problem. If it's gone up, then we need to look at that.
Looking at those numbers there from Michael's, I mean, maybe those numbers are wrong, but that doesn't look like 2.5 seconds per init.
Well, that's just a compression, right?
That was just
That's just
all of the stuff involving copying back files and kernel modules around, I think, was what a lot. Yeah, I think it was the CPIO that was a significant amount of time rather than the GZIP at the end, as I recall.
Yeah, or just
It's
building
about
the nature in the first place, right? Copying around the files, which are probably not even in cache.
Right, well, yeah.
Can we pipe I mean, if we're CPIOing all of this stuff to disk and then compressing the image separately, maybe...
I think it's probably pipeline already.
It is pipeline
Oh, right.
already. There's... Yeah, I can't recall exactly where the slowness was. I remember profiling it once and working out roughly what was slow, but I don't have it in my head. We clearly ought to profile this. There was difficulty with. I think that making it run fast there's an awkward compromise between. Ideally, it would just make symlinks to a bunch of stuff and then CPI everything in or something. And there was some difficulty with getting CPIO semantics right on the other end, because obviously you want symlinks into user sharing run test tools in your I remember Maximilian Attens talking about changing the way that the copy CPIO scheme was going to work, but I don't have anything understanding on that.
CPIO is used for image transfers, right? And
Yes.
Linux image is not CPIO.
The Linux image, the Linux image line you're seeing there is mostly creating the end manifest, but
Yes, the init manifest is a CPIO image.
yes.
No, I meant the Linux image is, the timings for 2.5 and 15 seconds was for decompressing the Linux image.
That was for the GZ stage. Yeah. Actually, the other part of the Linux image bit there will be generating the grub menu. That, depending on what other file systems are there, because that doesn't always prove very wonders about. That will be making some contribution to. I'd like to know the relative contribution of the two of those. We have in the past gone and optimized the grub to avoid some pathological repeated reads, repeated on cache reads of things, but it's not been seriously optimized. We have also not, one thing I would say, we have also now started using a Fuse module to look into file systems. So we remember the problems with mounting hibernated file systems and so on. So we're now using grub's file system code to do reads, which guarantees that the kernel can't get in the way and replay journals and stuff. But that is, admittedly not very well optimized. So,
And-
yeah, maybe like that.
And the initial manifest is also called on various other packages, right? Like MD and grid setup and NVM and stuff.
Right,
So you could
and
actually
also-
call that at the end instead of.
Nice. Yeah, I mean, this goes back to the triggers discussion. That if we can manage to call the init manifest trigger only once at the end rather than after every configure pass that touches anything to do with it, then we could certainly reduce the number of times that's called. Would it, just as a very simple tweak to those stats, I know you said they weren't perfect, would it be possible to at least get the number of times that something was run?
Yeah, absolutely. So this is like the raw data
Right.
that we have. So we can.
Yeah, so you could exclude, take any contiguous block of mentions of a single package and count that as one.
Yeah, that's definitely possible.
When you have file triggers, do they trigger on empty directories in the package? So if you say something like interest user share man, and a package installs an empty user share man one directory,
It's done textually
on the file list, on the
on the
file,
on the
which might
file,
say-
yeah, on the file name that comes out of the archive.
Right, so empty directories would count.
yes, but I think you could put a slash on the end of your trigger. Let me just read the...
Well, I was thinking of empty subdirectories of the thing that I've declared an interest in.
Oh, I see. Yes, it would certainly trigger on empty subdirectories.
Can you do something like startup and start.gz match? I should go read the docs.
It's all right, I can read the docs, I'm here already. Father is not what happens.
So we need to see how far we can get with the data we have, because we don't have information. Yeah, let's just figure out how far we can go with the data we have. We may need to do more statistics based on what dpackage is doing, because app has only a really rough idea about what's going on. I would also like to point out that this is only really interesting when it comes to upgrading in general, like upgrading from one release to the next, because it seems like if we would do updates in the background properly with IO nice and with nice, and if this would all work, then it wouldn't really matter how long it takes, as long as the stuff gets installed and doesn't affect the user in any negative way.
Apart from probably if you want to reboot the machine and the system says, hey, you can't reboot right now, I'm in the middle of an upgrade, which will take 5 more minutes.
Right, this is why we have this minimal chunks mode, so that we order it in the smallest possible way, so that hopefully it takes only like 20 seconds for this one package that is currently in the chunk. Of course, if OpenOffice is involved, it will take a little bit longer, but we can only optimize it so far with the technology we have. Unless we would, install it in some snapshot, and then once it's finished.
Then you have butterfest performance.
Yeah, exactly. Then we have other problems.
Out of interest, does an intended upgrade also notices that the user might be requesting to install the software center or something like that? As this is also logged as an upgrade as well.
Yeah, it's a good point. It should use fdaemon to do the actual installing, so that software center can just push itself in between in the queue. That's a good point.
What, so you can do an install while an upgrade is running?
Okay, more about. So that if there are upgrades in the background being applied and somebody wants to install a game, we shouldn't, block it. We should still allow this user to, push his game into fdaemon's queue.
Why not? That's a bit ambitious, isn't it? Okay. I suppose it would be nice. It's surprising.
Yeah, it's you get into this. Basically, you need to calculate the future state of what is going to affect that.
Any further suggestions? Anyone? started this discussion based on the preliminary data we had. So it's the action items that will help us and properly find out what is the problem here. So let's discuss the action items. First, we have the gather data action item for from example auto upgrade tester. As we have discussed a number of times, some triggers are run, and the number of seconds it takes to run them, time spent for each state, in each state. So, for example, downloading, unpacking, configuring, posting triggers. So I'll do this one. The other ones I don't really know. So let's discuss who wants to take which one. So we have test using the my data package to see how much fsync contributes. Okay, that's MVO. Test different options like no triggers, default with auto upgrade tester to see differences it makes. That's MVO also. Optimize the init RAMFS generation. First figure out what takes time actually there. No, that's not MVO. Who wants to take this one? One? Okay, we'll mark it as it's waiting for a volunteer. And make unattended upgrade use fdaemon its future state concept. I guess that's also MVO.
But I will not make any promises on this, but it's definitely a very interesting problem to look at.
Yeah, okay. Okay, I'd have one question regarding these action items. If not using the auto upgrade tester, how can we gather any test data? So could we use, for example, bug reports? So logs from bug reports we have, which were not successful, obviously, because there were bugs, but we have some data there. But of course, this should not go into the major data we get with the upgrade tester, because it's not the same if you have a full upgrade or only an unsuccessful one with only some packages updated. But it might help us to figure out what it takes, how much time it takes for any packages we didn't have in the auto upgrade tester test we made.
So we currently don't write this profiling data by default on upgrades. You need to explicitly enable it in some hidden configuration file somewhere. So that's not going to be very useful for most users. I mean, there's no overhead really in writing it. We could just as well write it.
Right, you're having to read it anyway.
Yeah, exactly. In order to display progress information and all this stuff. So
is it not in? Is depackage.log not timestamps?
is it?
It is, but yeah.
I don't think it is. Is it?
Strangely from.
It is, yeah.
Oh, is
Pretty. Why is it strange? I mean,
Yeah, it's not timestamp.
Well, it's not something. It's useful for reading. It would be helpful for profiling if it has more precision. Precision.
Yeah, so that's.
No, that's a good point. Data collection using depackage log as well, and seeing what we can extract from that is, and double check with the other data in order to see if it's actually reliable. That's a good point.
Yeah, sorry about that. The log seems to be in local time zone with no time zone information. My bad.
Did you do depackage log?
Yeah. I think so.
Maybe we can ask, I don't know, you know, involving the community more, asking people to send in this kind of information like a depackage log file, writing a depackage log file analyzer, having a wiki page, maybe saying if you have like if you do a test upgrade anyway, you know, you could provide us the data. It may be interesting to check it on you know, a slower or fast machine, doing, you know, using an SSD drive or traditional drive. It's a matter of collecting this data and also having useful ways to aggregate it.
Yeah, that might also setting up a wiki page for
Yeah.
community just to have them on how to send us some profiling data
Yeah.
from their real systems, which
Right.
are not virtual machines.
Yeah, that's, I mean, it's a problem with the auto upgrade tester because it's a virtual machine, it has standard hardware, some stuff, as Colin pointed out, grub may contribute more if you have Windows installed on your machine as well, or other, you know, other weird operating systems.
I'd rather give myself a couple of specific profiling approach items.
And this wiki page we can also use to publish the data, like to publish stuff like what results do we get with eat my data, what results do we get with no triggers by default and all this stuff. So this will be a useful point of, and hopefully we, you know, find stuff that is worth optimizing. All right.
Okay, so that was all. Thank you all for the discussion, for the suggestions. We'll see what we can get out of this.
Yeah, thanks for your session. It was quite productive, I think.
Thanks. It was your